Welcome back. In this, the final video of this series, we'll be examining prescriptive process monitoring. What is this, and how does it differ from the six-stage diagnostic process mining approach we've been discussing so far in this series? Well, simply put, diagnostic process mining approaches are reactive. In other words, they look for the causes of problems that have already occurred and look to implement interventions or solutions that will prevent similar problems from reoccurring in future. For example, throughout this series, we've used a real-life event log from the Business Process Intelligence Challenge from 2017, capturing the loan processing for a Dutch financial service firm. In the second video, we define the problem statement as you can see on screen. Now, each of these problems has already occurred. The customer has already declined the offer. However, we aim to learn from these and put in place interventions that will prevent this problem from reoccurring in future, that will make it more likely that customers will accept the offer they've been given. However, with prescriptive process monitoring, we adopt a proactive approach. We look at in-flight cases with the help of a predictive process monitoring model. We seek to identify which cases are likely to be problematic. We then apply the appropriate intervention to prevent these problems from occurring. As shown, this is a two-stage process with a predictive and a prescriptive phase. Let's first consider the predictive phase. This is the first part of the workflow. What is predictive process monitoring? That is a definition from the literature. Predictive process monitoring involves exploiting information for completed cases to make prediction for in-flight cases. Let's illustrate this with our event log. Now, in our event log, we have rich data on the path completed for completed cases, how long it took between activities, and the eventual outcome. For example, for client A, as you can see on screen, their offer was cancelled because it was declined. For client B, the offer was accepted, same as for client C. So when client D's offer is created, the logical question is, what's the likely outcome? Is this offer likely to be accepted or declined? Predictive process monitoring enables us to answer that question. Let's dive into this in a bit more detail. Predictive process monitoring is often done in two phases. First, an offline phase. And in this phase, we utilize historical traces or complete traces for complete cases to build a model that will predict the likely outcome of an in-flight case. We divide those historical traces into buckets, and one common way of doing this is by using the trace length, that is the number of activities executed to that point. So here we see a bucket containing trace length 1, here trace length 3, and here trace length 5. These buckets are then used to build predictive models. This is also referred to as the offline phase, as this step is done offline to speed up the execution at runtime. We then use these models in the online phase to predict the outcome of the case. Let's look at this from another perspective, looking at the end-to-end workflow with our event log divided into complete or full traces. We then bucket those traces, encode those traces. We talk about encoding later on in this video. We use those encoded traces to build a predictive model. This is the offline phase. We then have an online phase where for an in-flight case, we assign the trace to a bucket, the appropriate bucket, encode the trace, determine the appropriate model, and we predict the outcome. And this is, as we mentioned, the online phase. So having examined the predictive phase of the workflow, let's look at the prescriptive phase. Now, the objective of this phase is to determine where a case is predicted to be problematic, the appropriate action to take. Should we intervene or not intervene to prevent that undesirable outcome? We have a number of decisions to make in order to do that. The first decision is to determine the intervention frequency. In other words, how often and when to intervene. And we have two options. First, the continuous intervention, where intervention is prescribed for multiple or all cases in an activity. The other option is discrete intervention, where we intervene where the need is identified. The second decision we need to make is the intervention policy. In other words, what are the set of rules that govern what intervention is appropriate? For our use case, we establish the policy as follows. When the predicted intervention uplift is greater than the predicted non-intervention uplift, then we intervene. We extend the payback period. Otherwise, we don't intervene. It's also possible to consider multiple interventions from different perspectives. For example, in addition to recommending an activity, the prescriptive model could suggest that a particular member of staff execute the activity based on their schedule or expertise. Let's bring this alive and look at the end-to-end workflow. You'll recall that the problem we're looking at is the lower than expected acceptance rate. And one of the interventions we've explored is extending the payback period from 100 to 126 months for customers with a credit score of 0. We'll continue with this problem and intervention for the purposes of our illustration. Now, you can see an application in progress, and we see that the offer has just been created by user 28. For a use case, we decide on discrete intervention, and the ideal point at which to intervene is when the offer has been created for the customer. Where that is the case, we run our predictive model to predict the outcome. As you can see, 6 activities have been executed thus far. We want to know whether this user is likely to accept the offer or decline it. So we encode this partial or incomplete trace. The first 10 column of the encoded trace, as you can see there, contains the static attributes. These won't change. However, did you notice we also have 6 columns on the right indicating the activity label and a count of how many times that activity has been executed? So if an activity is re-executed, that count will go up by 1. And if a new activity is executed, we'll have a new column. This way of summarizing the case in one row is called frequency encoding. And it's one way of encoding the status of a case. There are other ways this can be done, but we'll stick to this one. We'll then pass this data into the appropriate predictive model. This is the predictive model for trace length 6, because that's how far along we are in our journey. The output for that model is the likely outcome. And in this case, the model predicts that the client is likely to decline the offer. So the question is, what should we do to avert this undesirable outcome? Should we intervene, extend the payback period for this customer, or not? Our prescriptive model helps us to answer that question. So we pass the data for this customer into the uplift model to obtain a recommendation. And the output from the uplift model is a row with two columns. The first is the probability of accepting if we intervene, and the second is the probability of accepting if we don't intervene. So comparing those two columns, we notice there's a higher probability of accepting if we don't intervene, and that's a recommendation not to intervene. Now, let's briefly discuss one limitation of the prescriptive process monitoring approach we've just discussed. Some interventions may prove ineffective due to second-order effects. In other words, an intervention may have a consequence that in turn has another consequence. For example, say we predict that a case is likely to be late, and as a result, we intervene and get another staff member to work on it. This might result in the cases that person was working on being delayed. Having said that, this is an area of research that has great promise. I would recommend that human judgment is included in the intervention process. The prescriptive model prescribes an intervention to a human agent who then assesses any second-order impact and decides whether to intervene. So let's briefly conclude by discussing some resources for diagnostic and prescriptive process modeling. At the beginning of the series, I mentioned that I was aware of one process mining vendor that implemented causal inference tools out of the box. And I did promise that I would reveal who that vendor was. Well, drum roll, it's Apromore with ProLift. And that video there shows you how that tool works. Of course, with other tools like Celonis, using their machine learning workbench, you can also implement these causal inference techniques. Also, the open source process mining tools such as Bupa or PM4Pi, where you can implement these algorithms. In terms of open source libraries that enable you to implement those tools, Python, we have EconML, Causal ML, and DoY. And for R, the libraries such as Uplift, which sadly has now been archived, or tools for Uplift. Having said that, this is a growing area of interest, so I expect that more and more libraries will be made available. This brings us to the end of this series of videos on diagnostic process mining. We've not covered everything because of a desire to make it simple and accessible. I've deliberately left out some of the maths and the detailed code walkthrough to make it simple to explain and understand. Also, there are multiple ways of doing some of the tasks we've accomplished with advantages and disadvantages over our chosen approach. If you'd like more detail, I'll post some references in the link in the comment section. Thank you for joining me on this journey, and all the very best as you implement these techniques in your organization. If you have any questions or require assistance implementing any of these, please feel free to contact me.